Okay, what I'm doing now is I'm testing for flexibility on the tailstock when I'm drilling a hole and the tailstock is under pressure. I have a 7/16 drill bit and I'm drilling aluminium, 1-inch aluminium, and I'm starting without any center or anything, and I'm going to try drilling a hole right from the start one, and we'll see just how much the needle on the dial moves, which indicates some form of flexibility. So I'm going to try drilling now. Little drop of cutting fluid. Now, as you can see, it's looking like it's about 6 thou flexibility on the front face, and so there is flexibility there. Now I'll swivel the camera around, hopefully, and you'll see the cutter with the material that it's cutting. And remember that there's no pilot hole, nothing in this piece of aluminium rod. So I'm putting pressure on now, and it's showing 5. It's showing, oh, it's moved a little bit. It's on the index of 5, or the numeral of 5. So now I'm putting pressure on, and there's flexibility of 5 thou, 4 to 5 thou, but you can see how this drill is cutting into aluminium. I think maybe I touched the dial with my hand, but anyway, under these circumstances I don't consider that is excessive, bearing in mind that the leverage is not like a standard tailstock, which is fixed to the bed and which is central with the bed. The amount of pressure is being cantilevered from the back of the bar, so I'm a little bit surprised that there is as much as that. As you can see, it's still cutting well. The swarf is coming out nicely, and I'll just swivel around to the dial indicator again, and as you can see, it drops to 5. I'll move that round if I can. It's on 0 now, and you'll see that to get that cut on a 7/16 drill bit, I believe it's 7/16, there's a flex on the tailstock itself of between 5 and 6 thou. So it's not really as good as it should be. Obviously there's some flexibility somewhere, and I suspect that it could be the 2 posts at the back. But it all depends on what you want. You don't bore, or you don't make a accurate hole by using a drill bit. If you actually need an accurate hole, then you have to drill undersize and either bore it out or ream it, and do it in that fashion. Yeah, it's 6 of one and half a dozen the other. The drill, when the drill starts to bite into the material, the drill will centralize itself up to a certain extent. So I really am not going to worry too much about it. I've got a hole in there now, which if I wanted it 1/2 inch, then I could then drill it in this fashion, and it would be a 1/16 of an inch undersize, which is sufficient to get a sufficient meat to clean up to 1/2 inch by boring and reaming, and I don't think it's really too much to worry about. I don't know what the situation would be between centers. There's obviously going to be some flex by the pressure of the revolving center in the end of the shaft, but that's something that would have to be calculated out, I guess, and allowed for, which is what I'm hoping this will achieve. I've got something else here that I might as well show you, which I intend putting on. I have a, what did I do with it? Yeah. I have this 1/4 inch micrometer spindle. It just moves out a 1/4 of an inch, and the intention is that by placing it in a block such as that, and placing the block on the bottom part of the sliding block, I can then calculate how much I need to move the micrometer thimble forward, and that will act as my second stop. Now, I can also use that if I'm doing any centering work. If there is a certain amount of flex at this end which puts the centers out, then hopefully I'll be able to adjust by using this micrometer thimble and for fine adjustment. So I guess we'll have to wait and see what happens. This is all really development, and with development you have these problems until you sort everything out. So anyway, the tailstock is doing fine. It's not a Hardinge lathe. It's what I consider to be a roller skate. So you get what you pay for. So I guess I'll leave it at that.